G'day. What a treat. What a treat for me and for you, dear viewers. This is David Merrill. He is the CEO and founder of Elroy Air. And I've only just realized that Elroy is the youngest of the two children in the Jetsons. That's how behind the drag curve I am um, in modern thinking or being on trend and trendy. But David's company has recently launched their brand new platform, pre-production platform, and he's kindly agreed to show us around it. So David, thank you very much indeed. I like the old platform. What was wrong with the old platform? I like that very much indeed. Why so many big changes?
It was good, but sure, I'll give you a little history. First, I'm speaking to you right now from the Hiller Aviation Museum in San Carlos, California. This is actually one of my favorite museums. It's got all kinds of historical and some recent aircraft. I'll give you a little 360 here. We've got our aircraft here, the pre-production Chaparral C1 vehicle, on display by invite of the Vertical Flight Society, who had their transitioning vertical flight meeting conference this week. So what we're looking at here is the pre-production Chaparral article that we're now getting ready to start flying this year, putting it through envelope expansion validation. It is a bit different than the full-scale demonstrator that we built and flew just before COVID in 2019. So to your point, yes, it's an updated version of the aircraft. The key things that we wanted to do with it there were just a number of improvements we wanted to make. And some of the things about this aircraft are that it has distributed electric propulsion. So on the main wing, we've got these pylons that have distributed propulsors for forward flight, 4 of those, and then 8 of the vertical flight motors to power the vertical flight mode. So this is a transitioning vertical takeoff and landing aircraft. Goes up and down on these eight rotors and then transitions into a wing-borne mode of flight for the long-range part of the mission. And then, I guess I'll point out the key things that are unique about this aircraft. This is a cargo drone, so it's made for logistics, for middle-mile logistics, for shippers running commercial cargo, parcel, humanitarian aid, and military resupply. And so there's a couple things that we've done very differently about the design of this vehicle versus, say, an electric air taxi, which in some ways it's similar to. It's about the same scale. It's all electric propulsion. But we've built a system for automated cargo handling. So you can see this silver pod underneath the vehicle. That's like the trailer to the truck. If you think kind of the analogy to drop freight with trucking on the ground is that we've designed a very efficient way for the aircraft to pick up and drop off cargo by taxiing to and then picking up this cargo container, flying it from A to B, and then depositing that cargo container at the destination. And then the other really different thing about this vehicle versus most air taxis is that this is a hybrid electric powertrain. So we've got a much longer range than a pure battery electric system. It's kind of like a Prius.
Well, you mentioned that. I think I saw there's a turbine hiding inside there, isn't there?
There is, yeah. There's a turbo shaft engine. That's why we've got this exhaust port right here. And that's really the key to a much longer range mission capability than a pure battery electric aircraft of this scale would be able to achieve. Important for our shipping customers for logistics.
You straight away jumped to it's a cargo drone. It's a little like AAM, UAM, whichever we want to call it. I'm going to defend you or comment for you, I suppose. But surely you're leading the way for them. They're playing around in jets and dreams, whereas you're doing the real thing, the real deal. It should be the other way around. They should be looking towards you guys and your marketplace, because your company is one of the only, and the cargo delivery drones that I bother following. There are 5, and it's less than 5 of all of them out there. There's so much sizzle within that market. So don't be afraid. Don't be afraid. You're
Mhm.
first.
Yeah, no, I think you're totally right that there's a cohort of OEMs, of vehicle makers building electric aircraft at this scale, and our thesis that I'm not shy about at all is that cargo is going to come first. That we will
Yeah.
get flight permissions, that we will scale operations out ahead of air taxi, because
Mm.
it's a much simpler mission. It doesn't rely on consumer behavior change to scale. It's a lower risk mission. There's a lot of reasons why we can build an enormous business that scales earlier than air taxi.
Absolutely. Did I see and tell me again, you probably said it, what sort of weight? Oh, look, there's an AA machine hanging up there. What
Yeah, there it is.
what sort of weight are we talking about lifting again?
Yeah, so it's designed for 300 to 500 pounds of cargo in the payload, um, and a 300-mile range with full payload.
And is that payload been split up into divisions there, or whatever you're calling the truck part of it?
It is. It's a single unified volume for now. This is actually an updated version of our cargo container that's on this vehicle, which is it's more of a pallet load. So I think, can't remember. I gave a talk at the Vertical Flight Society yesterday where I showed a bit of the concept of operations of like how the loading and closing of this payload pod works. But essentially, you can load up boxes or other items onto a flat pallet and then slide the aerofairing across and then snap it shut.
And so you can't. And does when you're loading that pallet, is there some sort of way of measuring how you are loading it across that area? You can't put a ton of lead in the front of it and it will go horribly wrong. To handle that change in weight and balance and all that sort of thing.
Yeah, it's a kind of a belt and suspenders approach where there's some training that will provide for the operators that are going to be loading cargo containers. The aircraft itself, however, does have the ability to ensure that it's not grossly misloaded. So as the aircraft picks it up, it can tell if it's way out of CG.
And then Maru's asking in the comments, sort of Masaru. Sorry if I'm getting that wrong, Masaru. I did it again. But how much fuel does it take?
Gosh, I don't remember exactly how big the fuel tank is, but I can give you kind of a sort of tour of what's in it.
Yeah, please.
So if you look at, you're obviously looking at the outside of the fuse here, but inside the fuselage, you've got the engine and the generator up front. You've got the fuel tank in the middle. You see the refueling port. And then you've got the battery system, so redundant battery strings for safety, and the avionics suite largely lives at the rear of the fuselage. And then there will be command and control, like antenna and the tail back there. One of the things that you can't really see it because it's in this configuration, but we have built the aircraft for transport with the ability to rotate the main wing so that it can line up with the fuselage and pack the aircraft into a standard shipping container. So for sending this vehicle out to a deployment location, you can kind of fold it up like a transformer and stick it into a shipping container.
What's that hanging out underneath the nose? You've got this. Is that a LiDAR?
That is a LiDAR. Good eye. It is. So that's for our ground navigation and safety when the aircraft is taxiing to pick up a cargo pod or drop off a cargo pod. So it has a full kind of 360-degree view around it using LiDAR units at the front and the back. And that makes sure that it doesn't bump into anything as it navigates on the ground.
And just to confirm to Martin, who's asking again in the questions, it's a VTOL. Yes, it's a VTOL, isn't it?
Yes,
and
VTOL.
the separate lift thrust. Yeah.
Yep, that's right.
And where was the design decision with not going for having some form of complex moving motors to transition to forward flight?
Oh, good
You've
question.
got both there.
Yeah, we got both. So we have a dedicated set of vertical. Actually, while this is moving, I'll show you the cargo container coming down here. So there it goes. And then the grasping robotics is now retracts back up into the underside of the vehicle for stowage. You can get a sense of how the cargo pod drop off works, and then think in a moment it should repeat the cycle and then pick up the pod. So you can see
And that
this
would move in operation. That would move the aircraft would move itself out of the way. Then would it?
That's right. Yeah, here in this museum, there's not enough room to taxi around, but the aircraft itself has powered taxi wheels, and it does taxi itself.
So that's it's a full rover on the ground as well. Then, so the wheels don't retract or move or do anything in flight. They stay in that position.
No, they stay in that position. They don't need to. It doesn't fly fast enough where that would be kind of a real needle mover. So we decided to not retract the landing gear.
And then, so it's already that's two sort of very practical considerations. Well, you might as well just keep the wheel there because the complexity will go through the roof. And I assume then also the advantage of swiveling motors and doing all that sort of thing is like, yeah, that's a bit too complicated.
Yeah, that's exactly right. We looked at it. You know, there are some other VTOL designs like the Joby vehicle and the Airbus Vahana vehicle where they've got either tilting motor pods or a tilting wing segment, and can be done, but it adds mechanical complexity, it adds weight, and then it also adds the necessity of developing a control system that gracefully handles vehicle dynamics all the way through this continuous change in rotation of a major vehicle component, which also can be done, of course, like the V-22 Osprey does it, but it just adds a lot of complexity, which equals time in a development program. And so we decided, let's keep it simple. We'll have separate set of propulsors for vertical flight from the ones for forward flight, and then it just makes the problem sets that we need to solve much easier. And overall, we're trying to optimize for speed to the market, to get this vehicle deployed, operational, doing useful work for customers. And so whenever we have a chance to do something a simpler way that's going to do the job, we usually opt for that.
And are there full flying surfaces on the wings and on the tail as well?
Are there control surfaces? Is that the question?
Yeah.
Yes. Yep. See if I can give you a view down at some of them.
And do they have? So are they redundant, or are they
just?
They are.
Yep, they're redundant. So you've got two segments of this outboard surface. You got an inboard surface here. Same thing on the other side. You've got two separate redundant pieces of this one, and then same thing, 3 segments up here. So wherever possible, we're creating a redundant aircraft where there's no single point of failure.
And could I kind of see when you walk around the back there where the curve of the rear of the wing is that's where part of how you can tilt it for transport, or that's the area?
Yeah. So let me give you a quick tour of that part. So you can't see it because it's covered up right now, but there's a circular bearing at the center point of the wing, which allows the whole thing to turn by 90 degrees and go from being, orthogonal to the fuselage to in line with the fuselage. And then when it does that, in order to have room back here for it to swing all the way, you can see there's this part line here where the back part of the tail can fold down, and that gives the wing enough room to swing all the way across.
And so you put that in your wish list. How far up your wish list was being able to just chuck it in a shipping container fairly easily?
It turned out to be pretty important to some of the early customer work that we're doing. And I guess I'll say that, the other kind of dimensional thing that fitting in a shipping container allows for is fitting into a C-130 aircraft.
Yeah.
And so some of our defense partners that fly a lot of C-130s are very interested to be able to take a Chaparral, put it into a C-130, fly it somewhere, and then pull it out and have it set up for a mission quickly. and can't be an IKEA project when you get to that other end and take half a
Yeah.
day to get it ready for a flight.
Yeah. Hello, Bella. Hello to everyone joining us in the comments. Bella says, mighty fine looking bird. I think we answered earlier, but we can go
Thank
again.
you.
That turbo shaft, is it purely a generator? Are the small wingtip props the only forward propulsion?
Yes, and there are 4 forward propulsors. So you can see we've got one near the wingtip, one sort of mid-wing on this side, and then the same on the other side. So the forward propulsion, it's all electric. So it's a series hybrid architecture where the job of the engine and generator is to charge the battery and then provide some live electrical power to drive propulsors. But there's no direct drive from the engine out to turn a prop.
And also being asked about the flight controller. What flight controller's in it?
Oh, it's a custom flight controller that we've developed with a partner, and I can't give details of exactly who or exactly what, but it's quite redundant. There's a lot of separate boxes around the aircraft, each of which has the capability to take over if needed. And so, kind of along the theme that I mentioned before about no single points of failure, we're making sure that even if one of the avionics boxes blinks out, there's plenty of other ones that can all take over and do the job.
I'm not seeing a pitot tube anywhere. Is there a pitot there somewhere?
Not yet. I mean, there's a few things like that we need to install before we enter our next flight test campaign. But yeah, there will be one on the front.
On the ground, is it dual RTK GPS to help with the compass and stuff like that? How are you doing, or is it purely LiDAR based navigation when it's on the ground?
Oh no, there's also GPS based navigation. So it has actually a couple of GPS units on board. When you've got multiple GPS, you can actually use that for yaw determination, which is a bit better than a compass, because there's a lot. Imagine with a electric propulsion system of this scale, there's a lot of electromagnetic stuff happening when it's up at full power, and a compass can get pretty confused.
Absolutely, yeah. No, it's kind of a miracle thing. A friend of mine has just started doing that as well, and it's sort of course. And then again, that's quite hard. Some big hard sums in there. It's very, very interesting.
Yes.
Squish is asking who's the flight controller partner. Yeah, still a secret. We'll find out. Don't worry. We'll find out, Squishy. We'll have people. We'll send someone there. We'll soon have that apart. It's no, it's an amazing machine. So I suppose elephant in the room for all things us at the moment. Well, first of all, several elephants, a whole herd. Detect, sense, and avoid, ADSB, and all that good sort of thing. Is that all on board?
Yeah. So not all that hardware is in here right now at this moment, but the integration model for Chaparral into the airspace is that it will participate in the airspace like any other GA aircraft. It flies autonomously, but the rules for that in the airspace aren't fully worked out. So we're going to have a ground pilot who has the ability to speak through a voice relay, talk to air traffic control, files a flight plan, ADSB in and out on board the vehicle. So it'll look like any other GA aircraft that's up there participating in the airspace. And then that integration model might be a little bit different in other parts of the world, depending on kind of what the local rules are. But that's the plan in the early days when the full kind of ATM network is not yet up and operational.
And your application for certification must be at the bottom of a very big pile of UAM, AAM vehicles now, because they're all going to get certified next year, if we're to believe lots and lots and lots of things. But so you must be right down the bottom of that pile of forward-looking people. No, but obviously certification. How do you see that? Is it going to be certified to a mil spec or a civil spec or nothing?
Well, in the fullness of time, it will have a type cert with the FAA, so we're in that process. However, we have customers in parts of the world where they won't need the full FAA certification to be completed before we can get operational. So, that's kind of an interesting nut to crack for a system, a company building a system like this, where there is a very serious regulatory aspect to a deployment. And so our approach is we work with, early customers who don't need the full certification to be completed, like the Air Force, like commercial shippers for humanitarian and commercial parcel overseas. And then all the while, we'll be moving through the type cert process with the FAA so that popping out the other side of that, we're able to scale into the US airspace as well.
Max asked, can it land like a conventional aircraft?
In theory it could, but that's every piece of scope adds development time. So at the moment, we haven't designed the landing gear for conventional takeoff or landing. It's only designed for vertical takeoff and landing. And so you can see we've got it's optimized for its ability to navigate on the ground. So it can go and pick up cargo containers and put down cargo containers. So it's something that we can revisit if we need to in the future. But for now, it's a VTOL aircraft.
And then Martin asked, has it test flown yet?
This article has not yet. We're working toward that this year. The previous full-scale demonstrator that we built and flew in 2019 did go through a test flight campaign. And then we brought that system back to our shop, and that's become the demonstrator or the kind of development system for the ground navigation systems and autonomy. So this is on the path to flight test now.
So if I came to you now with $1 bazillion and I said I want 10 of them, is there a big thick manual already written for how I'm going to operate it? Would you let me operate it, or would you bring in people to operate it for me, your guys to operate it on my behalf?
Yeah, we'd operate it for you in the early days, and that's how we're planning with our customers who want to be some of the earliest. Is that we'll come in and we'll be operating for them, or we'll be kind of hand in hand, shoulder to shoulder operating with them in the early days, because we don't have that big thick manual written yet.
Yeah, it's an amazing space, and I think delivery drones are going to, and ladies and gentlemen, boys and girls in the comments, if you've got some more comments, I know David's a very busy chap there at the museum, so I wanted to close this with him very shortly. So get your comments or get your questions into the comments now. This is a very exciting space, and it's very wise to have concentrated on this range. There we are. What was the range? I think you said it was 300 and 300, basically. Was that 300,
Yep.
300, 500? Yeah.
300 miles of range with full payload. And payload is 300 pounds to 500 pounds, depends on density, altitude. So it'll get, more payload at sea level than it will taking off at 6,000 feet.
And there we are, Mark, both been answered there. Can it land on a moving platform like an LCS's flight deck?
Yes, there's no reason why it couldn't, other than kind of working through the concept of operations and, maturing that behavior.
Well, you've been working with Agility Prime, that's the Air Force, and Lockheed Martin, Mesa. Of course, I'm scrolling through your website now to make you not pulling them from the top of my head. Embraer X and NASA. And the Navy as well. So a lot of people must have a lot of requirements chucked in that pot and for the manual.
Well, we've been designing Chaparral to meet sort of the intersection of the Venn diagram between commercial logistics and military and humanitarian logistics. And so, we're not going to build 5 different aircraft variants. What we're aiming to do is build a single aircraft variant that meets a really urgent operational need for both commercial shippers that want to do more express in more places, air cargo to places where you couldn't do air cargo today, as well as that, defense and humanitarian, where you're going to get resupply, get materials out to places where there just might not be another way to do it. So yeah, it's in our interest as a small company trying to build a focused product line to build the single system that can serve that variety of use cases.
And the C2 link, the command and control link, can you divulge who's running that? And does it have SAT-based stuff? Is it 4G, 5G, right, or any other stuff?
Can't divulge that yet.
Okay. String, long piece of string, control line. No, it looks like an amazing bit of kit, David. Thank you very, very much indeed for taking the time out to talk to us. I will watch its development with, or its flight test program with very great interest. Congratulations to you and your team on having a sensible outlook on all of this thing. And we look forward to seeing you again. Dear viewer, wherever you are in the world, thank you very much for joining us at sort of late notice. Look after yourselves. Don't forget to join us 21 GMT every Tuesday when we talk nonsense. Cheers for now. Oh, hang on. There's another question. Was there any consideration to making the vertical propellers single blade with a counterweight instead of double blade like the Stalker? Well, that's a big question.
Not that worked its way up to my awareness. But
yeah,
you
I
never
think
know. I know our engineering team thought about a lot of things and considered a lot of things on the path to developing the Chaparral. So it's possible.
There we go. All right. And with that one, I will say goodbye. Thank you, everyone. Two button clicks. See you on Tuesday.
Thanks for having me on the show.
Thank you. Bye-bye.
Take care.